One of the most amazing things to see isn't even here on planet Earth. They're actually located over 25 trillion miles away. They appear to us in the night sky as little white twinkling dots. They are a common symbol for divine guidance and even protection. By now, you probably know I'm talking about stars, of course. But what if I told you I'm talking about the little white twinkling dots in the sky? They're way more than just stars. And in fact, we can see less than 0.000004% of the stars in just our own galaxy. On a clear moonless night, you can see around 2,000 stars if you're far enough away from city lights, which is actually pretty good considering that we can only see around 4,500 stars with the naked eye, the rest appearing during the daytime when the sun pretty much fills the entire sky with its light. Now, it's important to realize that the closest star to Earth is still over 25 trillion miles away. That distance is equivalent to traveling around the circumference of the Earth 1 billion times. And even with current technology, it would still take about 137,000 years to get to this relatively close star. Also, some of you may be pointing out that technically our sun is a star. And yes, that's true. But because it's only 93 million miles away, wouldn't that make the sun our closest star? Well, let's see. The sun is classified as a G2V star, with G2 standing for the second hottest star of the yellow G class of surface temperatures about 5,800 kelvins, and the V representing a main sequence or dwarf star, the typical star for this temperature class. These types of stars are called G stars because of the prominence of a band of atomic and molecular spectral lines that physicists designated as G. The majority of all the stars in our galaxy, and actually in the entire universe, are main sequence stars. Our sun is a main sequence star, along with Proxima Centauri and Sirius. We're pretty serious about stars. Main sequence stars can vary in size, mass, and brightness, but they are all doing one thing: converting hydrogen into helium in their cores, which is why they produce such a large amount of energy. For a star to be located on the main sequence in the HR diagram, it must be in hydrostatic equilibrium, which basically means pressure balances the gravity. It also must be in thermal equilibrium, or energy generation balances luminosity. And it must generate energy by burning hydrogen into helium in its core. But wait, what is the HR diagram? The Hertzsprung Russel diagram, or HR diagram, is a graphical tool that astronomers use to classify stars according to their luminosity. It came about from some charts begun in 1911 by the Danish astronomer Ejnar Hertzsprung, and independently by the US astronomer Henry Russell, which also explains where the name came from. On the diagram, stars are ranked from bottom to top in order of decreasing magnitude or increasing brightness, and from right to left by increasing temperature or spectral class. Stars of the galactic arm in which our own sun exists tend to fall into distinct regions on the diagram. This group of stars is called the main sequence. The main sequence extends in a rough diagonal line from the upper left of the diagram, hot and bright stars, and to the lower right, dim and cool stars. The giant sequence of large, bright, though cool stars appears in the upper right, and the white dwarfs, dim, small, and hot lie in the lower left. Our sun lies near the middle of the main sequence. So is the sun the closest star to Earth? The simple answer is yes, at about 93 million miles away. But that might not be the exact answer we're looking for. Outside of the sun, our system's nearest neighbor is Alpha Centauri. This isn't a single star, it's actually a triple star system, or 3 stars binding together by gravity. Alpha Centauri A and B are 2 bright, closely orbiting stars with a distant, dimmed companion Proxima Centauri. To the unaided eye, these stars appear as a single star in the night sky as the 3rd brightest star, but it lies 4.37 light-years away from the sun. It's actually the faint Proxima Centauri that is our true nearest stellar neighbor at only 4.24 light-years away, or 0.13 light-years closer than Alpha Centauri A and B. I know it's hard to conceptualize this really vast distance, but just think of the sun as a grapefruit. If you wanted to get from your grapefruit-sized sun to your grapefruit-sized Proxima Centauri, you would have to travel around 2,500 miles, or 4,026.36 kilometers. That's about the distance from coast to coast on the continental United States. Once we have an idea or model of distances in space, it becomes easier to conceptualize these large distances. The Sun is roughly 93 million miles away from Earth. 1 light year is about 5,878,500,000,000 miles. To travel the distance of a light year, you'd have to move around the Earth about 236 million times, or travel from the Earth to the Sun 63,237 times. 1 AU, or astronomical unit, is exactly 93 million miles, or 150 million kilometers. Now imagine our solar system at the scale where the distance between the Sun and the Earth is exactly 1 inch, and replace light years with miles. With this scale, Proxima Centauri is 4.24 miles away. Alpha Centauri A and B are 4.37 miles away, followed by Barnard Star at 6 miles. Wolf 359 is 7.8 miles away, and finally, Sirious, also known as the Dog Star, is at 8.6 miles. With this scale visualized, we can make almost any distance in the observable universe easy or easier to comprehend. And also, before you watch any more of my videos, go check out my friend's channel, Gamer Squad. The link to his channel is in the description down below. And I know it's been a little while since some of our last videos, but don't worry, we have many videos in the making, and 2 or 3 that are actually coming pretty soon. And once again, thanks for watching.